And welcome to the UBC Best Year-End Showcase for 2016. Tonight is a night where we showcase our projects and really show you guys what we've been up to over the past year. My name's Julie Kerr, and I'm in my 4th year mechanical engineering in the biomedical option here at UBC. I'm the COO of UBC Best, and I work with Blake to manage and run the team.
My name is Blake Henderson. I'm in my 3rd year of mechanical engineering, also in the biomedical option, and I'm the new CEO of Best, working with Julie over the next year.
So just to give you a brief idea of what we're going to go over this evening, I'll give you a very brief intro about BEST. Some of you may know what it is, some of you may not. We'll then detail about our International Medical Device Initiative. We'll then hear very brief project updates from each of our project leads, and then we'll go on to tell you a bit more about our community involvement and future plans. So UBC BEST is an extracurricular undergraduate student team with focusing on the development of medical device projects. We have 80 members spreading across 7 different faculties and 6 different engineering departments, and we are working on 7 separate projects. And we are also very proud to say that our team is 50% female, so that's a number that we're very proud of. The goals of UBC BEST are threefold. First and foremost, we're focused on the development of context-appropriate solutions to medical challenges worldwide, which can be demonstrated from our International Medical Device Initiative, as well as our more locally based projects. Secondly, as a student team, we're also very focused on the technical and professional development of our students. And third, we're promoting entrepreneurship within biomedical engineering, because with the local industry, there's a lot of startups, and it's a very good side of engineering to be aware of. Just briefly, our management team consists of myself and Blake as the executives, as well as all of our project leads, as well as our business lead and our HR specialist. So you'll meet them very shortly.
So one of our largest initiatives to date was the International Medical Device Initiative. This took place just over a year ago. About this time last year, we were arriving back from 3 weeks in Uganda and Kenya. So Andrea Marshall, Marisha Jabowski, and Georgia Jabowski, and myself all traveled to Uganda and Kenya for 3 weeks to speak to medical professionals firsthand about the challenges that they face in delivering patient care. So we were there on an investigatory trip, trying to understand the situation and the context so that we can develop context-appropriate medical devices or medical solutions to help optimize their patient care. We started our trip in Uganda, where we were graciously hosted by the Makerere University Biomedical Engineering students, and there we spent most of our time at the national hospital called Mulago. This was their largest hospital in the country, so it was very interesting to see many wards, but a majority of our time was spent in wards such as orthopedics and trauma. While we were there, we were also able to go into the neonatal wards and get a better understanding of the overarching problems that medical professionals face. Another exciting part about our time in Uganda is that we were able to go to a regional referral hospital. So this is outside of the capital city. So this is much smaller, more rural. And we were able to watch the biomedical engineering students there as they fix medical devices. Here we were exposed to some of the challenges that they face with equipment maintenance and the issue with donated medical equipment, which Georgia will tell you more about later. Following our time in Uganda, we then went to Kenya, where we were in a northern town called Nanyuki, hosted by Dr. Richard Lester from the UBC Neglected Global Diseases Initiative. So although this was a much more rural hospital, it was actually quite a bit more developed and clean, which we weren't expecting. There we were able to delve more into the problems that we saw faced in Uganda, as well as see some other wards such as OBGYN, surgery, and maternal health, as well as ambulances. So following our time abroad, we came back here to this exact room and hosted our International Medical Device Initiative debrief session. So this was an open debrief session with medical and engineering professionals from the local community, and we shared with them the different things that we saw over our time abroad. We're also able to thank our very generous donors, Dr. James McEwen, who's here tonight, Mr. Paul Geyer, and Dr. Ken Spencer. So we thank them very much for giving us the opportunity to go see these challenges firsthand and really start developing our projects with our team. So during our time abroad and following, we are actively developing proposals for different medical devices and solutions that our team could work on over the following year. So we came up with 36 different proposals, which we surrounded in a large formal document where we were writing about our trip findings in a report. From those 36 proposals, we decided on 5 different projects to pursue on behalf of the International Medical Device Initiative, which you'll see here tonight. We also have 2 other projects, the Infectious Diseases Emergency Aid EMR system, which stem from the Ebola Aid Initiative, as well as our Music to Movement project, a stroke rehabilitation project, which has been going on for a number of years. So now, instead of me telling you about all the different projects, we'll let our project leads come up and tell you a bit about each of their individual projects. So first up is Respiratory Rate Monitor, and project lead Karen Woodward will explain.
Thank you. All right, so this is a challenge that was initially brought to us by a pediatrician in Uganda who expressed the need for a device that actively monitors the respiratory rate of patients and alerts healthcare professionals when that breathing rate changes from normal. Further investigation showed that respiratory rate is often very difficult and time-consuming to take and is often neglected as a vital that should be actively monitored. So our team is developing a device that is able to adjust these needs. We are currently working on 2 prototypes that both use different technologies as a means to measure respiratory rate. Our first device, as you can see on the slides here, uses an accelerometer to measure the change in acceleration of the patient's chest wall corresponding to respiration. Our second device uses a conductive fabric that changes inductance as it is stretched. This is used to measure the changes in the patient's abdomen circumference corresponding to respiration. Either device will ultimately be equipped with a way to display the respiratory rate to doctors, as well as alert healthcare professionals when that breathing rate changes from normal. Respiratory Rate Monitor has also had some really positive feedback in the past year that we're excited to tell you about. We were semi-finalists in the Pacific Venture Capital Conference and competition hosted by the Sauder School of Business earlier this semester. We were one of 6 finalists shortlisted for the McEwen Family Quality of Life Prize and finalists in the Medical Device Development Center Student Awards. So we're really excited with the progress that we've made in this past year, and we're eager to see what we can do in the next year. Hot.
Hi everyone, my name is Rahat. I'm the project lead for phototherapy team. Our team is trying to make the process of phototherapy safer in low resource settings. This was brought to us in the neonatal wards, obviously. So this was our first proof of concept. Here we're trying to monitor light and give you information about it, tell you how intense it is, what color light it is. And while this circuit is cute and all, you wouldn't use this in a real hospital. Right now we're working on our first iteration prototype. It's a lot more robust. We're measuring light a lot more accurately. And this is just a schematic of what the overall device will look like. We were also finalists in the MDDC award, Student Awards, and we got a lot of good feedback, some constructive criticism. And so to act on that feedback, we're going to take a step back and look at the problem once again. And hopefully through this iteration, we'll end up with something that will help people in the end. That's it.
Hi, I'm Georgia, and I'm the project lead for the Femur Fracture Treatment Project. So trauma is a major cause of death and disability worldwide, and motor vehicle accidents are the leading cause of non-fatal injuries, with femur fractures being the most common musculoskeletal injury. Surgery is a primary method to treat femur fractures. However, effective surgery is not easily accessible to patients in low-income countries due to factors such as cost, limited surgery time, and infection rates. As a result, patients are treated with other methods, most commonly with traction. Traction is a non-surgical method of realigning bones through constant force applications that is commonly used in low-income countries as it is a method that requires few resources and is deemed non-surgical. It constrains a patient to a bed for 2 to 4 months and is accompanied by a number of complications such as pin tract infection, malunion, and non-union. On the IMDI trip, we recognized it as an area which we believed could be improved through a mobile traction device. We spent the beginning of the year and the project validating the need for improvements to traction treatment and further researching the complications of not only traction, but also the setting in which traction is used. We did question, however, whether to improve femur fracture treatment through surgical improvement or through traction treatment. However, it came down to knowing that the reality for so many patients in these settings is that the most effective treatment, surgery, is not accessible to them, and they are going to be put in traction. And in these settings, traction has little been improved since it was first created in the 1900s. So it's very archaic and needs to be improved. So traction, yeah, it's not the ideal method to treat femur fractures, but it is a reality for a huge number of patients in low-income countries, and there is a huge need for improvement for it. So this confirmed our decision to develop a mobile traction device for low-resource settings. The device will align and maintain alignment of a broken femur through application of a traction force pulling the lower fracture site down, as well as a counter force which will maintain placement of the upper fracture site. Current traction treatment constrains a user to a bed for 2 to 4 months. Our device will be compact and allow the patient to be mobile from the bed. Our long-term goal is to implement the device in a system in these settings where part of the treatment with the device can be done at their home and with check-ins from their local rural health facility. The regional health clinics that traction is usually performed at are very over-constrained in terms of bed space and doctor time. By allowing this system where the patients can go home or go to their local health facility, it will really free up lots of the doctor's time and the hospital resources, as well as hospital cost and patient cost. Okay. I am also the project lead for the Donated Medical Equipment project. So also on the IMDI trip, one challenge that was repeatedly mentioned to us by biomedical engineers and by healthcare professionals was medical equipment donations they were receiving were largely, although they did make a positive impact sometimes, a lot of them were unusable or broken, and so they were unable to use them. The World Health Organization put out a statistic that in some countries, 80% of their healthcare equipment is funded by international donors, and a large portion of that, up to 70%, is not able to be used in those hospitals due to challenges with the donation process. From our research into the donation process and its complications, we found that a main challenge that prevents donated medical equipment from working in recipient countries is that often all the environmental considerations of the recipient country are not considered and are not adapted to the device. For instance, such as the fact that some hospitals in low-income countries have very limited access to replacement parts and consumables. By understanding that if you donate something that is broken or something that will need a replacement part or a consumable and you do not provide that in your donation, that's understanding that that device will largely remain broken or will be unusable in the future for that hospital because they simply do not have the resources or the technical capabilities to maintain that device and to fix it. A successful donation should contain an in-depth needs assessment and adapted to fit the setting. Following a set of comprehensive guidelines, such as World Health Organization guidelines, is key to successful donation. So after having developed a good understanding of why donations are unsuccessful on the recipient side, we started to look at the donor side. So what's happening in Canada? Why are donations unsuccessful? What process are charities following? So we contacted a number of charities and organizations to see, and we asked questions, we put out a survey and asked questions like, are you following any guidelines, for instance, the WHO guidelines, or is there a systemized process in Canada that you follow? Our findings were, although there are a lot of organizations that follow guidelines, there were an equal amount that didn't follow any guidelines at all. We also found that there was no comprehensive Canadian system or regulations in place specific to medical equipment donations. We also found that Canadian charities do not communicate with each other, nor are they aware that there are other Canadians donating medical equipment. They do not share best practices either. We also found that hospitals are very reluctant to donate medical equipment because there's no systemized place in systemized process involved and no platform in which they can do so easily without a huge liability issue. So the consequence of not having a regulated system or an enforced guideline is that anyone can donate a medical equipment despite its condition, and they may be doing so in goodwill without understanding some associated impacts it could have. So from our findings and our discussion with charities, we believe that a way to improve the donation system, specifically in Canada, is to implement a systemized process through policy implementation. So what we have done is we've created a draft policy which outlines a systemized process, it outlines guidelines and a way in which donors can follow it and donate properly. And we're going to get together with charities that we have identified and are continue to identify who are interested in improving the donation process in Canada. So we're going to get together and they're going to edit and revise this policy, and we are going to try to submit it as a collective unit. That is our goal. Thank you.
Hello, everyone. Detecting malaria with a microscope and a cell phone. That's what doctors in Uganda are trying to do, and we're trying to help them do it. So, as you can see on the picture on the left, they had designed a device that held any cell phone to any microscope lens and reliably, solidly, and with precision was able to take repeatable pictures of blood smears to detect early malaria. So they approached us, UBC Best, and UBC Best approached or put out an application and hired myself and my colleague Sophie to improve upon this green design you can see here. So that's on the right, there's a mid-iteration. We have part of our final, or finalized to this point, design printing on 3D printer, probably annoying you guys in the back there right now. And we are trying to make this more reliable, more robust, and a little bit better than what you can see on the left. The main problems with the left, if the table was bumped, the camera might go off. It's more of a clamp design, it's a little more difficult. We're trying to get full XYZ variable precision and the ability to fit a larger variety of phones. Where we're at right now, we're interfacing modules of holding the phone with moving the phone and clamping onto the microscope. So you can see where we're at. Come chat with us. We'd love to talk to you. Really excited about this project. Thanks.
Hello everyone, my name is Marisha and I'm the co-project lead of IDEA EMR with Ryan here. And some of you may know us from Ebola Aid, so our project came out of Ebola Aid, which used to be working with the Neglected Global Disease Initiative to design an electronic medical record system for infectious diseases. We've since pivoted and collaborated with IC Change, which is an NGO in Canada, to develop a trauma registry application to be implemented in Eastern Africa. So a trauma registry is a tool that hospitals and health systems use to collect information about patterns of injury within a population or a certain geographic area. They're widely implemented within North America, but they're yet to be fully implemented in Eastern Africa. So the proposal that IC Change came to us with was with developing this mobile form of the trauma registry that could be implemented in low-resource hospitals within Eastern Africa. So we've got a bit of a demo here to show you.
Yeah, so our team has been working in the last few months in collaboration with IC Change on an end-to-end system that involves both an Android mobile client, which runs on, I guess, mobile devices and also tablets. And we also built a server that will basically allow us to communicate both online and offline. So with this being deployed in Africa and Eastern Africa, the low resource settings would limit us in terms of like network connection. So we've built a system that's able to share the data across all tablets through a central server. So here's a quick demo, quick video. Essentially goes through the entire workflow of our app. Here we go. So we've developed a login process which allows users that are either healthcare professionals, doctors, nurses, etc., to authenticate, to log in to the service. Basically come up with a list of all of the trauma forms that they've recorded in the past and also here. So we're creating a new one, going through like the basic user information. And then on the other pages here, we have a bunch of standardized data points that IC Change has asked us to build so that we can, I guess, transmit to our servers, and they can do some analysis globally or on the entire population through these trauma centers. So here are some examples of the user interface that we've implemented to easily allow the doctors or the nurses or whoever is dealing with the patients to input the data.
So IC Change will be implementing this system this summer, so we hope by the fall that they'll actually begin the process of validating the use of tablets in collecting this type of information. And this type of information is really useful because it can identify holes within the trauma system and really shed light on how a country can improve their trauma system, which, like Georgia mentioned, in, for example, Kenya, it can be a huge issue and cause of death. So we're hoping to hear more from how this project is succeeding then. Thank you.
Hello everyone. Music to Movement, or M2M, is one of UBC Best's only non-IMDI related project. This year, our team has grown from 3 members to 14 members, and we are all dedicated to developing a music therapy device for stroke rehabilitation. Up here you'll see our 4 prototypes. We have 3 peripheral devices that target squeeze, tap, and spin motions and hook up to the hub for a whole system. So currently we're working with music therapists and also meeting with stroke patients to gain feedback on our device and further implement these changes in order to make for a better design and usability of our device. So this slide is dedicated to my team members that have been working hard these past years, and we're happy to announce that we have secured a place as finalists in the MDDC Awards for excellence in biomedical engineering design and innovation, as well as we will be heading off to Washington, D.C. to present at a conference as a finalist for the Rehabilitation Engineering and Assistive Technologies Conference. So our booth is right over there, so please come check us out and chat with one of these lovely faces, and we have a physical demonstration for you to try later on. Thank you.
I just want to further iterate, we are so proud of our M2M team. That competition is a national competition, and they're one of 6 finalists chosen out of 91 applicants. So we're very excited for them to go down there and present. In addition, you've just heard a very brief update on all of the projects. I highly encourage you to go around after this presentation and talk with them, ask them questions, and challenge them on maybe the development of their devices, and really get to know their projects. So now, in addition to all of this project development, BEST does a lot of community involvement as well. The medical equipment donations team, you heard, presented a workshop at the Global Health Initiative where they taught medical students and engineers alike about all the intricacies of this very important issue. BEST as a team recently has become involved with the MDDC over the past year, the Medical Device Development Center. The goal of this group is to deepen the ties between academics, industry, and healthcare, and now to include students within these links. And then in similar fashion, BEST has created its own board of directors, and we're actually having our first meeting tomorrow, so we'll see how that goes, to actually do the same sort of thing, to connect with the faculty, with the industry, and really get a good advisory board together. We've also worked with myself and another member, Amir, went down to Yale University for a weekend to the Unite for Sight Global Health and Innovation Conference, which is a very large conference where we learned about all the different issues and challenges that comes to having organizations come into these low resource settings, and so we learned a great deal about that, and we'll be hosting a workshop for our team on that at the end of the summer to really get back what we learned from that. We also do a lot of participation and outreach to the local community, so we always are involved with the UBC Engineering Open House. We host a number of high school talks, really trying to promote biomedical engineering to younger students, trying to get people to pursue their passions and to really become involved in the field. And yeah, we also participated within the UBC Global Health Conference, where Andrea hosted a panel as well, and Best hosted a booth. So we really get involved within the medical community. And then just recently, we've become more linked with the Faculty of Medicine, where they have this new Flex program, and it's a way for students in their program to pursue their passions, and there's a bunch of different sectors, and we've worked with the Faculty of Medicine to create a biomedical engineering sector where we've submitted all of our projects into their repository to give medical students the ability to work on our team without fully hindering their entire curriculum. So we have a lot of collaborations going on and a lot of community involvement, and not only do we want to develop these projects, but we also want to develop our members, so we try and get involved with the community as best as we can.
So as Julie said, in continuing along with all of that involvement, we also have some larger future plans for BEST. So first and foremost, continuing to cultivate our international relationships. So of course, going across to Uganda and Kenya, a big part of that was developing collaborations with people that understood the context. So we're hoping to continue to work with them, speak to them more and more as our projects develop to ensure that all of our projects are appropriate for the setting. We've also received very exciting news this past week. We found out that one of the students at Makerere University in biomedical, or actually two of the students, sorry, in biomedical engineering have recently got their visas, so they will be coming to Vancouver, hosted by Rotary International. So we hope to bring them onto the team. They were so gracious to us while we were in Uganda, so we hope to extend that same reach and have them work with us on our teams and have their amazing input on all of our projects. In addition to our international collaborations, we want to work with all of you to grow and develop the biomedical network. So as Julie said, a big part of our team is fostering biomedical engineering and entrepreneurship in the local community, and we hope to do that through collaborations with the biomedical engineering community, with the medical community, and especially with students here at UBC. We also want to deliver on our projects. So while we do have 7 projects ongoing, and it's a lot for all of us to handle, we do have a large team, and we hope to quickly move towards very context-appropriate solutions that we can actually implement into the settings and have them make an impact as we have been, all of our members have been desiring to do for the past year. And lastly, we want to increase funding to drive project development. So previously we haven't had consistent funding, so we hope to develop consistent funding each year, secured funding, so that all of our projects have the resources that they need. Along those lines, we are always happy to speak to any of you about possible collaborations with our team, whether you want to support us from an advisory or financial role.
Now, a very sad slide for us. We've had to say goodbye to 2 very key members of the team, Andrea and Elizabeth. Andrea left, graduated in December of this past year, and has now moved to Boston, where she's working at Haemonetics, which is a blood management company. Andrea basically is the heart of this team. She really grew the International Medical Device Initiative, was her baby. She dreamed it up and really delivered on it. So this team really wouldn't be here without her. So we missed her a lot. We're very happy to have her here back today. And a big congratulations to her, as she is going to have her wedding in 2 weeks.
We've also unfortunately had to say goodbye to Elizabeth, who was the CEO following Andrea. We are also very happy to have her back tonight. Although it's hard to see her go, she was a very integral part of progressing the team forward. In just her short 4 months as CEO, she really strove to develop our community here at UBC in Greater Vancouver. She developed our collaboration with the medical faculty, and has been doing an amazing job as continuing to support the team, as has Andrea, as we go to navigate without our 2 previous captains. She is currently in Toronto starting her own venture called Tandem Collaboration as part of Canada's Next 36 program, which is geared towards Canada's next top entrepreneurs. So congratulations to Elizabeth, and thank you for being here tonight.
ask you all to go circulate, learn about the projects, and really question our members, see how their devices are developing, I just wanted to open up the floor to any general questions for the team while we have everyone listening, if anyone has questions.